Good morning, students. So far in graphing, we have talked about standard form, which was ax plus by equals c. So standard form. Oh, I got this upside down. Hold on. All right, standard form. Just a review here. Hold on. Standard form. Which is ax plus by equals c. We also have slope intercept. Which is y equals mx plus b, where m is the slope and b is the y-intercept. And now we're going to learn a third one called the point slope formula. And this is the form of it. Now on a test, I'm going to ask you to graph it. I don't care if you use standard and you find that x and y intersects, or you do a t-chart, or I don't care if you use a slope intercept method where you find the slope and the intercept and then you move up and over as the slope indicates from the y-intercept point, or you can use this form. So we're going to just practice using this form. This form takes place when you know the slope and you know 1 point. Okay? So we're going to be building an equation based on knowing a point and one point and the slope. We're like detectives. We're gathering the clues, and then we've got to discover what the formula looks like. So we're going to graph lines given the slope and 1 point on each line. And then we're going to write the equation of lines given the slope and 1 point on each line. Then we're going to write equations of lines given 2 points on each line. And then we're going to write linear equations from information given in applied problems. So here it says, graph the line with the slope m equals 3/4, which passes through the point 4 and 5. So what I could do here, I know that 4 and 5 is on the graph. And so I can pull out the point 4, 1, 2, 3, 4, not 5, 1, 2, 3, 4. So 4 and 5 is like right here. And then knowing that, I can then just, from where I'm at that point, I could just move up 3, 1, 2, 3, and over 4. So it'd be like right here. Or I could go down 3. Oops, where did my other point go? 4, 5. Sorry. Or I could go down 3, 1, 2, 3, and over 4. And then I've got the points that I need. It just keeps disappearing on me, and I could connect them and make the line. Remember, this tells me how to move once I have a point on the line. Right, sorry, the slope tells me how to move once I find a point on the line. And since I could find 4, 5, I knew I could move up 3 over 4 or down 3 to the left 4. And I've graphed it. That's one way that we could do it. Well, let's look at some other information. And that's what it's going to tell us. Remember, our rise is up 3, our run is over 4. So once we plot the point 4, 5, move up 3 units and move to the right 4. And either way, we arrive at 8 and 8, just like I showed you. And there they are. Then we can connect those two. And there we are. How about this? If the line m equals a -2 fifths, so I'm going to go up 2 to the left 5 or down 2 to the right 5. This is going to be a negative slope, so I expect to see this line going like this. Here is my graph. And it says to go find the point -1 and 4. So right there. Then from that point, I can move down 2 and to the right 5. So that would be right here. Or I can move up 2 and to the left 5. And then basically I'm right here. What if I went down 2? That would have put me what, at 2. This should have been a little lower, sorry. 2 and 4. Or the point over here, if I went up 2, that would put me at 6 and minus 5 right there. So there we go. Because we're going to go to the left. So we have these points right here. All right. Let's now begin with another one. Let's just look at that quick. Clear that. Okay, the way we arrive at the point 4 and 2, which we did. So we could move from the given point with the rise first and then the run on our, or run first and then rise, whichever way you want to do it, but make sure you're making the right one. Now, let's go back here. So here they went over 5, down 2, or you could go down 2, over 5, as long as they were both, one was positive direction and the other one has to be a negative direction. Okay, because our slope is negative and it is slanting in the negative direction, so we did that right. So let's begin with the next one. We can instead use the point slope form where we know a slope and we know a point, and we can substitute them in and get an equation. And so we take this form, and the y value would go in the, well, it would go in the y1 spot, and the 1 goes in the x1 spot. And then this is the point slope form. And if you manipulate it a little bit, solve for y, it ends up looking like this. And so this is the final in slope intercept form. Okay, so this is slope intercept form. Notice how it looks different than the point slope form, or this was the point slope form right here. When you add 5 to each side, like they do, combine any like terms, you end up looking like this. Solve for y once again. Then this is the slope intercept form. All right. And if we multiply each side by 3, because we're going to try to make it be in standard form, so multiply by its greatest or its least common multiple, actually, least common multiple, yep. So we're going to multiply by 3. We end up with 3y minus 15 equals 2x minus 2. And we just rearrange that and we get 2x minus 3y equals a negative 13. Darn, wouldn't you know, a train would go rolling by at this point. All right. This is my least favorite form of a line of an equation because I can't really graph from it. Although I could say, oh, well, here's a point. That's the y value. That's the x value. And here's my slope. So I know I have a point 1 and 5 and a slope 2/3. And I could graph from there, find the point 1 and 5, and then go up 2 over 3. And I kind of get it right there. So I could use that, but I like the point slope form better. So now it says find 3 forms of the equation of the line with slope. So we have standard. That'll be the last one we find. Slope intercept. That'll be the second one. And the first one we're going to find is point slope. So we're going to plug this into the point slope form, which is y minus y1 is equal to m times x minus x1. And here's our x1, y1. So we're going to have y minus a negative 1 equal to a negative 5/2. That's our m times x minus 6. And just to clean that up a little, well, that would be y plus 1 equals a negative 5/2 times x minus 6. So that is point slope form. Okay. But if I go ahead and continue to solve for y, I would get y plus 1 equals a negative 5 halves x minus, but actually it's going to be plus because a negative 5 times a negative 6 is a plus 30, but divide it by 2, that's going to be plus 15. And then I'm going to subtract 1 from both sides, and so I end up with y equals a negative 5 halves x plus 14. That would be point slope form. And standard form, if I times everything by 2 from here, I get 2y equals a negative 5x plus 28. Bring the 5x to the other side so it's on the same side as y. 5x plus 2y equals 28. And that would be standard form. Notice that each form looks different, but they all will graph the same line. So even though they look a little different, they're going to all graph the same line. So here's point slope, y-intercept, and standard. All represent the same line. All have the same slope. All have the same y-intercept. And there we go. That's what they've shown us. Okay, what if we're only given 2 points? Can we still find the equation of the line? Of course we can. We're great detectives now because we've already learned that if I have 2 points, I can find the slope. And we just learned that if I have the slope and 1 point, I can write the equation. So the first thing that we would need to do is find the slope if we're given 2 points. Then we would second plug it into this equation and find the slope intercept, not slope intercept, but point slope form. Okay, so let's try that. Here we're given 2 points. So the first thing I want to do is find the slope, which is y2. I'm going to label these. That way I don't mess up. So it's y2 minus y1. And here's what often happens. People will go minus 2, and then they'll just put minus 3. But it's minus the negative 3. All over 5 minus a negative 1. So what we really get here is a negative 2 plus 3 and 5 plus 1, which happens to equal 1 over 6. So m equals 1 over 6. Now we're going to put it into this form, the point slope form. And so we call this x1, y1. So I'm going to take this negative 3 and put it in here. And this negative 1 will go in right there. So I have y minus a negative 3 is equal to, and here's my slope, 1/6 times x minus, and x1 is a negative 1. And let's take care of our negatives here. So we actually have y plus 3 equals 1/6 x plus 1. And if we wanted to put that in, we could subtract 3 from both sides. Well, first we'd have to distribute. So this is point and a slope form. And since it doesn't say which form, I could stop right there. But sometimes on the test, it's going to say, I want it in slope intercept form. So the next thing we'd have to do is distribute on the right-hand side. Then I'm going to add or subtract 3 from each side. Great. Now it looks like to combine these two, I need to have a negative 3 in terms of 6. That would actually be 18 over 6. That's the same as a negative 3. And now I can combine them. I get y equals 1/6 x minus 17 over 6, if I combine those two. That is my y-intercept, or my slope-intercept form. And then finally, we're going to put that in standard form. So I take this, and my denominator here is 6. So if I times everything by 6, 6 times y is 6y. 6 times 1/6 is just 1. 6 times a negative 17, 6 is just a negative 17. Then I can go, I'm going to subtract the x from each side. Let's go over here. So I end up with 6y minus x equals a negative 17. And then I can arrange that so it's a negative x plus 6y equals a negative 17. And I can leave it right there and we're good. We're in standard form right here. You can multiply a negative 1 through, but you don't need to. All right, let's look at that carefully. This just says find an equation. They're going to use the point slope form. And there they have it. You found your equation. But they're going to show you also what could I do if I wanted it in slope intercept form. There it is, just like we did. And then standard form looks like this. Notice they did make this negative through. Remember, we had a negative x plus 6y equals a negative 17. They just times the whole thing by a negative, and they got x minus 6y equals 17. All right, find an equation of the line that contains the points. So here we have the points again. Go ahead and label it. And the first step is to always, find the slope. Because you always have to have a slope in order to write an equation. The good detectives know I need a slope and I need a point. I already have 2 points, so I can find the slope. So y2 minus y1 over x2 minus x1 gives me a negative 2 over 7. So my m equals a negative 2 over 7. I can then put that into the point slope formula. Y minus y1, well, y1 is 3, is equal to slope times x minus x1. Well, minus a negative 2 is really like plus 2, so I'm just going to write plus 2. And there it is. I finished my equation. However, just to practice, if I want to make this into the slope intercept form, first distribute. Oops, we're distributing there. And a negative 2 times 2 is a negative 4 over 7. I'm going to add 3 to each side. But 3 in terms of 7 would really be like 21 over 7. And now I have y equals a negative 2 over 7x. And a negative 4 plus a positive 21 would give me 17, positive 17 over 7. That's my slope intercept. And finally, standard form times everything by 7. Get rid of the 7 on the bottom. I end up with 7y equals a negative 2x plus 17. I can add 2x to each side. 7y to 2x plus 7y equals 17. So I have found all three standard form. All right. They'll find the slope. They'll use those points. Look, they used a different point than I did, but look at that. It turns out the same. And I get the same slope intercept form and the same standard form. So it didn't matter which point I used. I could use either one, but I always just stayed with the one that I labeled X1, Y1. So here we go. we're going to find the equation of the line through the points 2 and a negative 4 and parallel to the line y equals 3x minus 1. Now, if lines are parallel, I believe, like, if we're going to escape this for a second, I want to go back to something we said a long time ago at the very beginning. I think it was here. Maybe not. And maybe it was in the chapter before. I'll find it. Yeah, I guess it was in the chapter before. But in the chapter before, we talked about parallel lines have the same slope. And that's really important to note because in this problem, they don't tell us the slope. They just tell us that it's parallel to a given line. Right here. It says find the equation of the line. Let's start it from our current side. To the point 2 and a negative 4, we do have a point, and parallel to the line y equals 3x minus 1. Well, if it's parallel, they have the same slope. So we're using our detective skills. If it's got the same slope as this line, what is the slope of this line? Well, the slope of this line is 3. This is in slope-intercept form. So we know the slope equals 3, and we know a point is 2 and a negative 4. Therefore, we can use the point slope form. So this is y1. So I have y minus a negative 4 equals our slope, which is 3 times x minus 2. And this really becomes y plus 4 equals 3x minus 2. We can subtract 4 from each side. And y equals 3x minus 6. And that is our point slope formula. And then if we wanted to put it in standard form, subtract the 3x from each side. And then what we can do is just multiply the whole thing by a negative 1. And that gives us 3x minus y equals 6. So that's standard. This is slope, intercept. And right here was, well, we'll go right to here, was point slope. All right. So let's just review this. What did we need to know? We needed to know the slope and a point in order for us to create an equation. Our detectives have to have those two clues. But they didn't give us the slope, but they did tell us that it was the line we're trying to create is parallel to this line right here. And we do know that parallel lines have the same slope. So I can use its slope as my slope for my equation I'm trying to discover. All righty. And that's what they're going to tell us. So we can use that same slope and they plug it in and they get what we got. Did I get 2? I can't remember what I got. All right. And if you graph them both, notice that these lines are parallel. Anywhere you look, they're exactly the same distance apart. All right, let's move on. Find the equation of the line perpendicular to the line 3x plus y equals 7. I'm passing through the points 5 and a negative 2. So we've got to find a line that's perpendicular to this line right here and passes through the point 5 and a negative 2. Well, I have a point that's 5 and a negative 2, but I need a slope. But what do I do about lines that are perpendicular to each other? What do I know about their slopes? Their slopes are opposite reciprocals. What does that mean? Well, if I had a slope of 1/3, the opposite would be a negative third, 1/3, and its reciprocal would be 3/1. So we're going to flip it over and change its sign if they're perpendicular. So take the slope, flip it over, and change its sign. In this case, let's look at this line. Let's solve for y in this equation, because that way it will tell us what the slope is. So the slope in this one, in this first line, we'll call it line 1, is a -3. But in line 2, we want the opposite sign, so it's going to be positive, and it's reciprocal. Well, a -3 is really 3/1, so if we flip it, it'd be a positive 1/3. And this is the line we're trying to find right here, okay? So now we know its slope, and we know its point, and we're ready to go. So we can say y minus a -2 equals the slope of 1/3 times x minus 5. And we can say then, just clean it up over here. And we are done. We don't have to go any further. That works for me. However, you can finish simplifying it and get it that way into slope-intercept form or into standard form. It's up to you. Let's look at that and see. So first they tell us, okay, well, if this line was a -3, the one that's perpendicular to it, that's our keyword or clue we had to sort, would have the opposite reciprocal for its slope. So 1/3. And we use the point slope formula. And there we have it right there. And if we simplify, we end up with x minus 3y equals 11. That's standard form. Okay? All right. So these lines are perpendicular. So if one line looked like that, the other one would cross over it just like that, forming 90-degree angles. That's the definition of perpendicular. Okay? And there they show it to us, and we've got 90-degree angles going on. So we have done it right. So here we have 3 problems to do. Is it 3 or, yep, 3. Write an equation in standard form. So standard form, let's remind ourselves what that is. AX plus BY equals C for the line with the slope 5/8 and that contains the point 2 and a -2. So I'm going to use the slope-intercept, which is y, not slope-intercept, but point-slope formula. So y minus a -2 is equal to, here's our slope of 5/8 times x minus 2. Now this is not standard form, is it? So let's go, we're going to get y plus 2 equals 5/8 x minus 10/8. And now we're going to add 2 to each side. I subtract 2, sorry, subtract 2 from each side. And 2 with a denominator of 8 would actually be like 16/8, right? So y equals 5/8 and -10 and a -16 makes a -26/8. But now we want to multiply the whole thing because we want it in standard form. Let's go up here a little bit. We're going to get 8y is equal to, there should be an x here, sorry. But if I go times that all by 8, I get 8y. Here I'm going to get 8 times 5 is 40. 40 divided by 8 is 5x. And it's a positive, so I don't want that negative. Yeah, here. And 8 times a -26 divided by 8 is just going to be -26. I subtract 5x from each side. I get a -5x plus 8y equals a -26. That's good. Or I could multiply everything by a negative and get plus 5y, make this a minus 8y, and this a plus 26. And that could be it. And this would be the answer I'm actually looking for right here. All right, let's do the next one. Write an equation in standard form. Once again, for the line passing through the 2 points, 6, 2, and a negative 3, 1. Well, first thing I need to do is find the slope. So I'm going to call this y2, x2, y1, x1. So y2 minus y1 over x2 minus x1. And I'm going to get a negative 1 over a negative 9, or 1/9. So my slope here equals 1/9. And then I'm going to put it into the formula. I'm just going to use y minus 2 is equal to 1/9 x minus 6. And now I'm going to distribute that through y minus 2. Sorry. Y minus 2. We're a little low on the paper here. Equals 1/9 x minus a negative 6 over 9 would be a negative 2 over 3. But let's keep it a negative 6 over 9. And then I'm going to add 2 to each side. Well, 2 with a denominator, if I'm going to make an equivalent fraction for 2, that's really going to be like adding, if I add 2 to this side, 2 over here with a denominator of 9, making equivalent fraction would be 18 over 9. And so negative 6 plus 18 is 12 over 9. So I have y equals 1/9 x minus or plus 12 over 9. This could be reduced down to 3 goes into that 4 times 4/3. But I'm going to keep it right here because we're taking it to standard form times everything by 9. I get 9y equals x plus 12. Now subtract the x, and then I give x plus 9y equals 12, or multiply a negative through, and I get x minus 9y equals a negative 12. Was that correct? Yep. Okay, and our last line. Write an equation in slope-intercept form for the line passing through the point, a negative 5 and 2, and parallel, there's my clue, it's parallel to this line. But I don't know the slope of that line. So I'm going to have to solve for y so that I can determine what its slope is. So let's erase here. First of all, if I solve this one for y, I'm going to get y equals a negative 3x plus 8. So its slope equals a negative 3. And since the lines are parallel, they have the same slope. So I'm going to write a line that goes through this point here and has a slope of a negative 3. So y minus 2 is equal to a negative 3 times x minus a negative 5. I'm using the points right here. And that's really y minus 2 equals a negative 3x minus, or a negative 3 times x plus 5. Then if I distribute that, negative 3x minus 15, y minus 2 over here. I'm going to add 2 to each side. And I end up with y equals a negative 3x minus 13. And that should be my answer. And that's what we got right there. Okay, so you've got to be a good detective. Find all your clues that are listed there. The clues were slope-intercept form, that it passes through, here's a point, and they're parallel, so I had to find the slope of this line before I could discover with all my clues the other line. And this is the line that I discovered with all of those clues. And remember, I have to have a slope and I have to have a point to be able to discover the line. All right, good luck on this one. This one, if you need to have a Zoom meeting or talk, please let me know, and have a good evening.